Hello there, Wildcats. Welcome to your Algebra 1 class. In this video, you will be learning about factoring polynomials. And we'll go over with the definition of coefficient, factors, GCF or the greatest common factor, and polynomial. Our objectives in this lesson will be to find the greatest common factor of the term of a polynomial, use the structure of polynomial and the understanding that polynomial form a system similar to integers to write it in factored form. And lastly, we have to factor polynomials that represent real-world problems. So in this lesson, we'll just only focus on factoring using your GCF. So our essential understanding here would be the greatest common factor of the term of the polynomial is the greatest common factor of the coefficients in the variable or variables using the number of instances of the variable that are common to each term. So let's proceed and let's take a look at what are the definition of terms that we'll be going to use in this lesson. So the first one, we have factor, either number or polynomials. When an integer is written as a product of integers, each of the integer is a factor of the original number. Meaning, if you are given an expression in a general form, what are we doing is we have to break it down into pieces. So that's your factor. When a polynomial is written as a product of polynomials, each of the polynomial in the product is a factor of the original polynomial. So if you have same as when you learn your multiplication, okay? So let's say 3 times 3 is equal to 9. So the factors of 9 in that situation is the 3 and 3, right? So the process of factoring is writing a polynomial as a product of polynomials. And as what I have said a while ago, we are going to focus on your GCF. And what do we mean by GCF or greatest common factor? Greatest common factor, it's the largest quantity that is a factor of all integers or polynomials involved. Okay, so these are the ways in finding the GCF. One is finding the GCF of a list of integers or terms is prime factor of the numbers. So you know already what are the prime numbers. So prime numbers, these are the numbers that only have one factor, which it's the number itself times the 1. And then second is identify the common prime factors. And then take the product of all common prime factors. If there are no common prime factor, the GCF is 1. Okay, let's take a look at this first example. So example 1, it's find the greatest common factor of each list number. So we'll just focus first on numbers before we dive into a polynomial, meaning we have the number, we have the coefficient, and then we have your the variable with the exponent. Okay. First is 12 and 1. So the first thing that we have to do is I'm going to write it in such a way that you will see. Just use pen here. Okay. I'll just change color of my pen. So first is 12 and 8. So we have 12 and then 8. So if I'm going to make this one and look for the factor, it's like 2 times 2, which is 4, 4, and then we have 3. So 2 times 2 times 3 is equal to 12. And then we also have here 2 times 2, which is 4, times 2, which is 8. So as we can see here, because the word is the greatest common factor, which is common to both of our number. So common to both of our number, we have here your The first is 2 and 2, and then the second is 2 and 2 here. So your GCF of 12, so GCF of 12 and 8 is 2 times 2, which is equivalent to 4. So the GCF of 12 and 8 will be 4, right? Next is, let me just erase that. Next is we also have to look for the GCF of 7 and 20. Okay, let's take a look at this one. So 7 and 20, if I'm going to write that, 7 and 20. So 7, the factor of 7 is just, this is a prime number because you only have one factor, which is 1 times 7. And then 20, the factor is 2 times 2, because 2 is a prime number, guys, okay? And then times 5, which is also a prime number, which will give us 20. Now, there are no common prime factor, so the GCF here, okay? There is no common prime factor, so the GCF would be 1. So the GCF of 7 and 20 is 1. The GCF of 12 and 8, GCF of 12 and 8 would be 4. All right. Another example here from, we have 6, 8, and 46. So 6, 8, and then 46. Okay, is equal to, so let's take a look at the prime factor. So 6 is 2 times 3, right? And then also 8 is 2 times 2, 2 times 2 times 2. Okay, and then 46, sorry, that's 46. That's 2 times 23. Basically, our GCF here, this GCF, would be the common to the 3, which is just the 2. Guys, do not multiply 2 times 2 times 2, okay? So it's common to 6, 8, and 46. So that's the common mistake there. How about 144? 144, 256, and 300. So what will be the common factor here? So 144 is 2 times 2 times 2 times 3 times 3. So that's 2 times 2 is 4, times 2 is 8, times 3, and then times 3. So 144. And also we have 256 is 2 times 2. And then another 2. So that's 3 2s, 5 more 2s. So 1, 2, 3, 4, 5. So there must be 1, 2, 3, 4, 5, 6, 7, 8 2s. Okay, for 300, that is 2 times 3, or 2 times 2, sorry. So 2 times 2, okay, sorry about that, 2 times 2 times 3 times 5 times 5, which will give us 300. So what are the common here? So the common factor that we have would be common, it's this 2 here, another 2, no more. So the prime factor, or the greatest common factor, the GCF is 2 times 2, which is 4. Okay, so those are our example. Next is find, let's now take a look at if the involves are your variables, which is just like in our example, first example and our second example. One way to identify the greatest common factor of a variable with exponent, take a look at the exponent. The lowest exponent that you have there, that will be the greatest common factor, as long as, if and only if, they have the same variable. Okay, just like in here. So I'll just show you how this greatest common factor look like when I am going to write it as a factor. So if I have x cubed here, you can rewrite this one as x times x times x. So there are 3 x's there. If you have x raised to 7, so there must be 7 x's, okay? So basically, instead of putting this 2, 4, 5, 6, and then 7, instead of putting 7 and then 3, just take a look at the lowest exponent, because you will see here that it is common to both is your x cubed. So your GCF basically on this particular example, so your GCF here, it's the exponent that has the lowest, the GCF here is the variable that has the lowest exponent. Okay, now let's combine them together with the coefficient and then the variable. In our example here, which is 6x raised to 5, and then we have 4. So we have 4 just erase that, and then so we have 4x cubed. Okay, so 6 is 2 times 3 times x raised to 5, or 1, 2, 3, 4, 5, and then 2 times 2 times 1, 2, 3. So we know that the common is 2, and then of course, as what I've said, it's the lowest exponent. That's 1, 2, and then 3. So your GCF in this particular example would be 2x cubed. Okay. Next example, find the greatest common factor of the following list of terms. So everything is a variable with an exponent. That's what I have said. Take a look at the lowest exponent. That will be the greatest common factor as long as they have the same variable. So a cubed, b squared, okay, and then a squared, b to the 5th, and then also we have a to the 4th, and then b7. Okay, so basically that's a times that's a times a times a times b times b. This is a times a, 2 a's, and then 5 b's, and then we have a to the 4th and b to the 7th. So what is the lowest? What is the lowest here? It's your a squared. And then what's the lowest for b? It's the b squared. Therefore, the GCF here is a squared, b squared. So what are we going to see here is, you notice that the GCF of the term containing variables will use the smallest exponent found amongst the individual term in each variable. Okay, as easy as that in factoring polynomial using your GCF. Okay, so let's take a look at the factoring polynomial step by step. The first step is in factoring polynomial is is also to find your GCF of all terms. Second is we have to write the polynomial as a product by factoring out the GCF from all of the term, meaning we have to regroup them. Okay. Usually in regrouping, in factoring, we made use of the parentheses, the close and open parentheses. And we have, lastly, the remaining factor in each term will form also a polynomial. Okay, so let's take a look at this first example. Find the GCF, or the greatest common factor, of the terms 12x, so we have 12x raised to 5, 12x raised to 5, and 8x to the fourth, and then we have negative 6x cubed. Okay, so 12, it's 2 times 3. And then I'll just put there x to the 5. Why? Because we know it already that we have to get the lowest exponent. And then we have 8 is 2 times 2 times 2 times x raised to the fourth. All right. And we also have the 6 is 2 times negative 3 times x raised to 3. We know that we have to get your x cubed as a part of the GCF. And then what is common here? It's the 2. So our GCF here would be 2x cubed. Okay, so that if you will write this one in factored form, so I will use the red color on the factor because it's the greatest common factor. The greatest common factor is 2x cubed, and then inside your parentheses, I'll put here parentheses here. So what are the remaining part here? So the remaining here, because you put the 3 here, this will be 2. The remaining here would be 2. Sorry about that. It must be 2. So the remaining here would be I'll just erase this one. So the remaining would be 2. So the remaining here would be 2. Okay, that's the remaining here. The remaining there is 2. So I'll put there 2 times 3 is 6 x squared. Okay, and then plus the remaining is 2 times 2, which is 4. And then there's 3 here. You have 4 there, so it's just x. Okay, minus, because it's 3, minus 3. And then you don't have any x here because you put here the 3 already. So if I'm going to do and use the distributive property, so you have distributive property, we have 2 times 6 would be 12, x cubed times x squared, that will give you x raised to 5. And then 2 times 4, that will give you 8. X cubed times x will give you x to the fourth. And then we have 2 times negative 3, 2x cubed times negative 3, that is negative 6x cubed. So this is now what we call now the factored form of that expression that we have there. All right. Another example, factoring out the GCF. So factor the GCF of each of the following polynomial. So let's do this one. So we have 6x cubed. Okay, I'll just I have to rewrite that properly so you can see it. Okay, so we have 6x cubed minus 9x squared. So also 12x. So 6 is 2 times 3 times how many x's? 3 times 3 times x. And then we have negative 9, that is 3 times negative 3. Just exchange this one. So we have negative 3 times 3 times x times x. And we also have 2 times 2 times 3 times x. Now what is common to them is that we have the 3 here. And how many x's? Just one x there. So I encircle the GCF so that you can see that your GCF now, it's 3 GCF. Oh, sorry. So your GCF here would be GCF is 3x. And then close and open parenthesis. Okay, and then take a look at the what remaining, that is 2 times x and x. So 2x squared. So that if I multiply 3 times 2 will give you 6. Okay, and then x times x squared is x cubed. Then minus 3x. So that if I'm going to multiply 3x times 3x will give me negative 9x squared. And then 12 is 2 times 2, which is 4, plus 4. And then do we have any x there? No. So as you can see, the one that I encircle, that's your GCF that will go outside your parenthesis. The remaining expression that you have there, the remaining term, will be inside your parenthesis. And we call this now as your factored form using your GCF. All right? Okay. Number 2 example. I have to erase this one because number 2 is at the bottom. So number 2, we will be factoring. So if you want to copy this one, you just pause this video and then you can copy the one that I'm erasing right now. And we'll go to the next problem, number 2. We have 14x cubed y plus 7x squared y minus 7xy. As we can see here, it's not just only one variable involved, but there are 2 variables, the x and the y. So the same way, guys. So I have 14x cubed and then y. And then I also have 7x squared y. And then we have negative 7xy. We all know that the factor of 7 is 1 times 7 times x times y. Same here, negative negative 7, the factor is negative 1 times 7 times x times y. Your 14, it's 2 times 7, 2 times 7 times x times x times x times y. So let's take a look at the common factor. The common here, it's the 7 and then 1 of the x's and then the y. Okay, so the GCF is 7xy. So GCF will be outside, so instead of putting that, okay, GCF is equal to 7xy. So in factored form, 7xy times, that's open and close parenthesis, so I can change the color of my pen here. So I have 2x squared, so you have 2x squared then 7 it's 1, which is x. So just put our plus of x minus, because it's a negative 1. It's just negative 1, right? Negative 1. So minus 1. So the factored form of 14x cubed y plus 7x squared y minus 7xy is equal to 7xy times 2x squared plus x minus 1. All right, so that is how we do factoring in using your GCF. If you have any problem, guys, with this one, join us in our live Zoom meeting every day. And also, do not forget that if you need extra help, we'll have a small group support during for math class. We have 9:15 to 9:45. I encourage you guys to use this video, encourage you to join us during live Zoom meeting, and also to get a one-on-one support for small group support, again, Monday to Thursday from 9:15 to 9:45, and also the we also have after school tutoring for math. All right, so thank you guys, and we'll see you in the next video, and hope to see you in the live Zoom meeting. Bye bye.